Okay, let's start page 10. 2a, differentiate with respect to x, continuation of page 9. So except, now we have a mixture of different functions, right? So 2a, we're going to take the derivative of x squared, which is just power rule, 2x, and the derivative of cosine x, which would be negative sine x, right? And no chain rule, that was pretty easy. C, derivative of e to the x times cosine x. Now remember, last time it was plus, so we could just take each derivative separately, but this is a product, so we need to use product rule, right? So let's take u and v. So first we'll do uv dash, so that would be e to the x times the derivative of cosine, which is negative sine x. I put a parentheses there so I show I'm multiplying, not subtracting. Then I do u dash, which would also be e to the x, because the derivative of e to the x is e to the x. And then I just write cosine x, right? So this will be negative e to the x sine x plus e to the x cosine x. Next one, natural log of sine x. So first we're going to do, this will be chain rule, right? And the outside function is natural log and the inside function is sine x. So the first thing we're going to do is we're going to take the derivative of the outside function, which is natural log, which is 1 over the something. So natural log of something is equal to 1 over the something being sine of x. And then you multiply the whole thing times the chain rule of the bottom part, that's the something. So that would be cosine x, right? The derivative of sine x is cosine x. And then if we simplified that a little bit, it would be cosine x divided by sine x, also known as 1 over tangent of x, but you could just leave it like this. Derivative of sine of 3x, that's a chain rule for sine. The derivative of sine of something is cosine of something, so we'll put cosine of the something. And then we just multiply that times the chain rule of 3x, which would be 3. So if we wanted to rewrite that without parentheses, we could write 3 cosine 3x, right? 3 tangent 2x. So the derivative of 3 tangent 2x, well, the 3 is a coefficient, we just leave it there. Then we take the derivative of tangent of 2x. Tangent of something, the derivative is secant squared something, or 1 over cosine squared something. So 1 over cosine squared 2x, the something, right? Last of all, we need to take it multiplied times the chain rule of the inside, which is 2x, so we multiply it times 2. If we want to rewrite that without a whole bunch of parentheses, we could put 6 divided by cosine squared 2x. And then k, I accidentally put k in the previous page, so I just copied the answer from the previous page for k. If you want to see the video for k, you can go back to page 9 video. Number 3, differentiate with respect to x, sine of x squared. And so this is kind of a continuation, different chain rule problems, different product rule, quotient rule problems. So the derivative of sine of something is cosine of something, right? So I just put cosine of something, and the something happens to be x squared. Then I take the derivative of the inside, the something, which would be 2x. And if I want to rewrite it, I could write 2x cosine x squared, and then I've rewritten it without parentheses. C, square root of cosine x. So this is a function within a function. The outside function is square root. The inside function is cosine x. So, the derivative, or the outside function being square root, we could rewrite this as cosine to the 1/2 x, right? And so the outside function is 1/2. So if we were going to take the derivative of this, first we would do the derivative of power rule. So we would get 1/2 times the inside cosine x to 1 less than the exponent, so it would be 1/2 minus 1, which would be negative 1/2. And then we would need to take the derivative of the inside function, which would be negative sine x. So if I rewrote this, it would be negative 1/2 sine x times cosine x to the negative 1/2. And if you wanted to, you could put cosine of x in the denominator and make it a positive 1/2 exponent, but not necessary. derivative of cosine cubed x. So the outside would be power rule because cosine cubed x is the same thing as cosine x cubed, right? So you put 3 times cosine squared x. That's the first step. We did power rule on it. And then we take a derivative of the inside, which is cosine x. So we're going to write, don't be confused by the fact that there's a 2 there, because this is just the way they happen to write it so that they don't need so many parentheses, but we could put the squared here, maybe it's more clear. Then I'm going to multiply it times the derivative of the inside, so negative sine x would be the inside. And then I'm going to rearrange it so that I don't need so many parentheses, so I'm going to put negative 3 sine x cosine squared x. Okay? G. So I have the cosine of x. So the outside function is cosine. The inside function is cosine. So the derivative of cosine of something is negative sine of something. So I'm going to put the something right inside like that. And then I multiply that, of course, times the derivative of the inside something, which is cosine x. The derivative of cosine x is negative sine x. Of course, we just did that. And then we maybe multiply the negatives together, right? The negatives cancel out. And then we're going to have 2 signs. One of the signs is just sine of x. The other sign is something more complicated. It's sine of cosine of x, right? Derivative of 1 over sine of x. Okay, so 1 over sine of x, that is the same as sine x to the negative 1, and I think it's a little bit easier to see how you would take the derivative of that in this form. It's a power, right? So we do power rule. So we're going to bring the negative 1 down. We're going to rewrite the inside, and then we're going to change negative 1 to negative 2 because we lower the exponent by 1, right? Then, of course, we need to do chain rule. The derivative of sine x is cosine x, so we're going to multiply the whole thing by cosine x. We could rearrange this. We put negative cosine x in the numerator, and then sine squared x in the denominator. Okay, so we have 2 over sine squared 2x. And you could do some weird form of quotient rule, but remember the top of this is just a coefficient, so I wouldn't do quotient rule if I were you. I would do maybe something like this, rewrite it so that it's in the numerator, and then it's just going to be chain rule. So remember, the outside function is the power rule, and so we're going to bring the negative 2 down, it's the exponent, right? And then we're going to lower the exponent by 1, so it's going to be sine it to the negative 3, 2x. And then, of course, we need to do the derivative of the inside. And just so that it's a little bit easier to see, I'm going to get rid of that, and then I'm going to put the exponent on the outside. It's a little bit easier to see that we do need to do power rule or chain rule of this whole thing here. So now we need to do the chain rule of sine of 2x, which would be derivative of sine of something is cosine of something, right? And the something happens to be 2x. And after we do that, we do need to do the derivative of 2x because that's another chain rule that we need to do. Okay? So now I'm going to multiply these coefficients together. So 2 times negative 2 times 2 is negative 8. And on the numerator, we'll have cosine of 2x. And the denominator will have sine cubed of 2x. Last couple. 4a. We're going to find the derivative of this, and then we're going to find the derivative at a specific point, x equals 2 pi over 3. Ah, yes, unit circle. So the derivative of sine cubed x, this is actually the same as sine x cubed, right? So if we take the derivative of this, we get 3 sine x squared. And then we take the derivative of what's inside, so that would be times cosine x. So if we rewrote this without parentheses, it would be 3 cosine x sine squared x. And then we'd like to substitute in 2 pi over 3, which is 120 degrees, right? So if you remember from your unit circle quizzes, 3 cosine x, that would be 3 cosine 2 pi over 3. Cosine 2 pi over 3 is -1/2. And sine of 2 pi over 3 is square root of 3 over 2 squared. So it would be -3/2 times 3 over 4, which is equal to -9/8. Last one, 4b. f of x equals cosine x times sine x at the point where x equals pi over 4. Okay, so let's find the derivative of cosine x sine x. That's a product, right? Cosine x times sine x. So we could say this is u and this is v. And so first we're going to put u cosine x, and then we're going to put derivative of v, which would be the derivative of sine. The derivative of sine is cosine, right? And then we're going to do u dash, which is negative sine x, right? Because the derivative of u is negative sine x. Then we multiply times sine x. Okay? And that gives us cosine squared x minus sine squared x. And cosine squared x minus sine squared x, that looks familiar. It's actually equal to the identity for cosine 2x. So we could rewrite it as cosine 2x. Now let's evaluate cosine 2x at x equals pi over 4. So we could put in pi over 4 here, and that would give us cosine of 2 times pi over 4. 2 times pi over 4 is pi over 2. Pi over 2 is 90 degrees. Cosine of 90 degrees is equal to 0. Okay? Or you could do it here, and cosine of pi over 4 is square root of 2 over 2. Sine of pi over 4 is also square root of 2 over 2. So basically we have square root of 2 over 2 squared minus square root of 2 over 2 squared. And so if you subtract those, you also get 0. So the answer is 0.